Today on Xenodiladon.
I figured let's do a complete teardown on a 3-way LCD projector. If you're wondering what make and model this projector is, here's the back panel for your viewing pleasure. It's actually a really interesting projector. It looks like that the board that controls the lamp power supply and the general power supply for the system is actually all on one board here on this back. So there's a lamp driver side here, and it looks like general power. Looks like we got a general power supply side. What looks to be a voltage doubler with those two large capacitors there to see how they're configured up in the wiring. And this whole section here, which is the side that the lamp gets the power from, comes around. This side looks like it's all pretty much lamp parts, lamp area. Get to that later on. But for now, we have the optical core, and this is a 3-way LCD projector. So we have in the optical core the red, green, and blue LCDs, and then that goes up to the front lens. It's a really big lens too. I mean, that's my hand. That's a pretty beefy lens. So yeah, let's take a look at this beast and see what's inside. Now I want to actually pop this off and pull out some of the LCD panels themselves and actually show you what those look like when they're running, and I'll flip them out of the optical core. Now this projector, ironically enough, it does work. The problem is without the remote, I can't really get to the VGA computer input, so this just solidifies my trust issues with software engineers. Alright, we get to the important bits right here, which is the optical core. It's actually pretty much covered with this thin metal dust cover here. It's a pretty nice dust cover. Well, you get a bigger screwdriver eventually. Oh, it doesn't like to come out. That's strange. Yeah. So you can get that one screw up and out. It's spinning, it's just making my life difficult. Not wanting to come out of that area. How weird. Well, we'll just fold that back then for the time being. I think what I'm going to do is I'm going to pull out this green plate right here, and I'll show you how that looks. So here's one of the 3-way LCD panels in the optics core. These are pretty old panels too. The density of the ribbon cable connections looks like it's really outdated. It's from 1998, so a 20-year-old projector. "20 years old, still works." Alright, with one of those pulled up and out, here's the panel. There's a little bit of dust on it. That's okay though. Let's fold that over for the time being. Get a power supply, plug it in. I can see more about that projector too, how it works. It looks like there's no safety interlock, so I should be pretty much safe to just plug this in and carefully avoid electrocuting myself on the power supply. On. Fan spin. Got fan spin. Alright, here's one of the little display panels. I'm going to go up and bring the menu up, and you're going to see that the menu is going to pop up on the screen like that. And there's 3 of these. This one's for the blue. I'm going to put this piece of polarizing film behind it, and you can see what the menu comes into a little bit clearer of an angle. And yeah, there it is. And there are one of these panels that control the colors for each one of the screens. So if you see here now, nothing on the blue. I'll put this back into position now inside of the optical core. Kind of set it in there. It's not at all calibrated at this point. Bring up that menu again, and turn off the screen. And you can see, moving this around, that the image shifts a little bit. In the optical core, as I said, we have 3 areas of light that come in. This area we have the blue, which I just showed you. We have the green, so I pull this up now for controlling the green image. Pull that out. I don't think it's going to mind. So green light's coming in from here. We have a polarizing film. Same thing with the red over on this end. The red LCD panel, the polarizing film, and then the blue again here. So now with the green all exposed, we get a lot of green light coming out of there. Same thing with that. If I wanted to change that color, removing the blue, give us a slightly different color as well. And again with the red. So that's how this optical assembly works. And inside there's a cross cube that combines all those composite images. And those composite images, red, green, and blue, get sent out here after they're mixed. And of course, to keep everything in perfect alignment, these things are carefully calibrated to line up their images in perfect aspect. Over here, from the optical core, but right here we get the white lamp light that comes out of this area. And there's a bunch of different lenses in this area here too for processing that light, so it's a perfectly smooth image. Underneath this area right here, we have the logic board, and that basically just drives the video signals and handles the coding for that to get sent to the LCD panels in the 3-way optical assembly. Underneath that, we have the actual optical assembly for doing a couple of things. It's basically everything in here. Underneath this panel, you'll see that kind of a black box underneath. Inside that black box, what happens is it takes the white light that comes from here and it splits it off into a couple of different colors using dichroic glass. So for example, and we'll see the entire optical assembly later on, but basically it takes the white light and splits it off into its red and green and blue parts using those filters and different lenses to optimize the amount of light that comes out of the front of the lens. Yeah. See, I'm gonna pull this one up here. Yeah, it's not really too discolored. It actually looks like a pretty decent panel. These are really cool, by the way, if you have lasers. I'll talk a little bit more about these. The LCD panels work basically like black and white calculator screens do. So here I have a calculator screen, and the only difference between this and that is the amount of pixels. So this is all just little dots, where this is the characters. And if I peel this back, a 1-layer polarizing film, essentially you have the exact same thing. But this one has, as I said, the characters for displaying on the calculator, where this one has a dot matrix. And you can see if I take one of the polarizing films from the projector, the same thing will happen. So if I put that there, you'll see that it changes colors as I rotate it. And then with the LCD panel from the projector, you'll notice it does the same thing. So yeah, essentially there's little to no difference between these two, otherwise pixel density. And as I said, there's one of these for each of the 3 primary colors. Now, I also said these are really fun with laser pointers and lasers and such. So here I have a laser. If I shine it through this LCD panel, you'll see I get a bunch of dots, and get more dots coming out of that. Turn it off real quick, and I have more about this in other videos, but you get these really cool patterns that come off these LCD panels. And you can also split these with a torch or heat gun to get 2 panels So that way you have 2 panels worth of laser glass. Stupid switches. Okay, back at it, it's a really basic logic board, it looks like. And there's not really much going on to it, a lot of analog components. Not too much that I really see that's digital. And a couple of digital components, such as a couple of analog to digital converters and vice versa on there. It looks like they actually have the entire operating system of the projector on one of these little rewritable EEPROMs. Now this looks like a UV erasable EEPROM. Let's take the sticker off of it. These were really popular years ago. They were on everything. And how these things worked is they were microcontrollers that you could put software on, and if you wanted to erase it, all you had to do was put this under a black light. Let me give you a little closer image of what that part looks like. But yeah, so right there, I'm betting is where all the software for this lies. I'll pop that little EEPROM out of there. Let's see. A little AMD EEPROM. Could be a whole. I'm not really sure what that is. Definitely an EEPROM of some sort, though. Right there. Oh, come on. There you go. So we have all the motor controls, and these go to different fans right here. It's a really weird. It looks like there's a motor control IC, H-bridge of some sort. I haven't looked up that part number. And then all these little ICs right here, probably similar little drive transistors or H-bridge controllers, and they hook up to the front lens assembly. So those motors have to go back and forward. So most likely something to do with H-bridge control. It's power input. Power input. And let's see. Look on the other side. Looks to be a bunch of fuses here, and then here's where the signals come in from the card on the side. Not much to it otherwise. It's a pretty basic board. Not really much going on. Alright, back to the inside of the projector. Alright, yeah, got a couple of lenses that are quite common in projectors like this. And they're multi-lenses. So you can see that there's a couple of lenses in there, and it looks like a 5x6 grid here. And there's often 2 of these. And what they do is they help correct the light that comes off the lamp, so that way it goes into a uniform, square, uniform direction, kind of blends more. We got the second of that pair, which is right over here. So the light from the lamp comes into here, and you'll see that there's this mirror section right here. That's the first surface mirror, and after that it gets reflected into this right here. Pull out those lenses. It's a pretty big lens. Put that one aside. And as I said, there's another lens right here. It's a bit of an odd one. Has a bit of a curvature to it. Come on out. There you go. Because this has this, looks to be a UV reflective coating, so that way, you know, the ultraviolet gets out of the lamp, and that can damage optics in your eyes and stuff. So it looks like it also covers the IR spectrum a little bit by the red that comes off of that. So it's a really weird optic. It's the first time I've seen an optic like this. Usually the filter is a separate part, and usually the lenses are much smaller on the optical surface. It's a really oddball one. Okay. So, as I said, we have the first surface mirror here. Well, we have a first surface mirror. I want to point out something. Alright, with this mirror thing here, I want to show you something. So, you'll see that sometimes people will say, if you put something against the mirror and there's no gap, that it's a mirror that's designed for a camera so they can spy on you. And as you see, this particular mirror, there's no gap at all between those reflective surfaces. They line up right away. So, I want to point out to you something real quick right here. I'm going to put the camera right up to this, and you can't see through this mirror. Like, so, yeah. Yeah, look at that, right up to the light. So, light and the mirror. So, just because you don't see a gap between the reflection and the mirror does not mean you can see through one of these mirrors. Actually, for aesthetic reasons, these mirrors look a lot better as far as reflectivity than a second surface mirror. Goddamn, quit your paranoid shit. You all know that cameras are small enough to go anywhere. Worried about mirrors. Mirrors aren't the problem. Cameras that are the size of a dime are the problem. Alright. We got the rest of the optical pathway here. And let's show you that. So in the optical pathway, we have the dichroic glass. We have one dichroic glass here. So what this dichroic glass does is it allows the red light to be mostly filtered out, and red light comes in through here, and this is a red reflect, so then it reflects the light in this way that's red. And if I pull this one up, you'll notice that it's reflective to basically everything else that is not red. So that means that it kind of filters out the light, the extra light colors, so the colors don't come in. Now, from here we have a reflection of the green and blue primarily, which gets sent into here, and this piece reflects off green, so the green is going to enter through this lens and out. And then from here we have the leftover blue and a little bit of green that comes out. Comes over to this mirror right here, which reflects the green and primarily blue light over in this area, and it hits this right here. And you see, if I lift this up, you see that you can see yellow through it. Well, that also reflects off blue as the opposite color of the dichro. So blue is reflected off, and that also helps eliminate any green scatter that comes off. And from there we have polarizing optics. I'm going to pull those polarizing optics right now, show you what those look like. So here's one of those polarizing films. I'm going to put it down just like that. There's 3 of these films inside of here, and sometimes they're actually different colors. And now, oh, that one's has a little nice dichro coating, a little extra filter in there. That's nice. I'm working under polarized light, so you can see if I tilt this, it gets lighter and darker as I tilt it. And for the red one, the other ones don't have any dichroic coating on them whatsoever, but same thing, if I tilt it, it gets lighter and darker. And if I pose it against that one, same thing. And yeah. So, a dichroic glass. Now, with every with every LCD device, polarized light is a very important part of the device, because the actual little crystal fluid that's in those little panels, which actually looks like this, it's a little vial of the fluid. The actual liquid works by polarization. So let's see how the optical assembly works, and by showing you how the dichroic glass works in principle. What I'm going to do is I'm going to take out all the lenses, and I'm going to shine a laser through the optical assembly, so that way you'll get a nice smooth idea of how the entire optical assembly reflects all those different light colors. So, that lens, careful with the glass. And there's that lens as well. So with all those lenses finally removed, we have a very straightforward optical path now. The optical path, I'm going to put that mirror back in. We have a complete optical path as it was in the projector. So mirrors in. So really straightforward. What's going to happen when the laser comes in? We're going to have a mixed laser source, red, green, and blue come in. That's going to bounce off that mirror. The red, green, and blue is going to be divided. So we're going to have mostly red that comes out here and red reflected off here. You're going to see that this green and blue is going to come off here. Going to come out here. Mostly green is going to come out here. A little bit of green, primarily blue, is going to come out of here. This area reflect off. Reflect through this area, reflect off here, primarily blue, leaking off some of the green in the back. Using a red, green, blue, and violet mixed laser, now we can take a look at the optical path. Let's see, that glass is a little tilted. I'm getting a lot of reflection back off that green. Okay, but primarily, white light comes in through here, comes off, just like I was saying. And mostly red light comes off here, but you'll see that there's a little bit of light that's not red, and primarily mostly red coming off of here once that additional light is filtered off. Now you got the green and blue light coming into this area right here, and you see you'll see the blue primarily pass through this filter and reflect off this mirror here. Behind here, you'll notice that there's a little bit of green that comes off. And that green is filtered off just by allowing it to pass through, and the remainder of the blue, you see nice blue come in here, it gets reflected off. All those colors, as I said, mix into the dichroic cube. Here you'll see primarily green coming off here, so you got red, green, and blue coming through the optical chamber. It's a really neat setup, and is what is inside most commercial video projectors that are the three-way LCD. So there's not really much going on. It's all basically built off the idea of the 90-degree, 45-degree angle interactions of light, and then just separating off the base components at this point. It gets a little bit more complicated with the polarizing inside of the dichroic cross cube. Once again, that's mostly just to allow the LCDs to run. And let's continue with this. Continuing with this teardown, I removed the lens assembly, and we'll get into that a little bit later on. For now, we're going to remove some of the extra pieces and get this case all disassembled and off the desk, so that way work with it. So here's the lower plastic frame of the optical assembly, which houses all of the dichroic materials. A very hard composite fiber. Also a high temperature plastic as well. That side. And got the dichroic cross cube assembly as well. And I'll get into that as this goes in a little bit. Oh, come on, who did this? Not even cool people. Oh, this is great. This is great. Oh, what the hell? You know, I didn't design it. This is ridiculousness. How many of these are there? Come on, that can't be how they're put in. Well, that was unexpected. Gotta go find a little long screwdriver now. Let's try it. There's the other one. under this wiring harness that holds in the fan wires. So these fans out. These are pretty nice fans. These are pretty good fans. Instead of a projector, 12 volts, 5.2 amps, quarter of an amp, about 3 watts. Yeah, not a bad fans. Well, they won't be the greatest. They're usually pretty quiet fans, so that means low RPM to cut down on the noise that the projector makes as far as like ambient noise and stuff. And, here we have right here the lens position, vertical lens position motor. Ah, okay, I understand now. That's what drives that motor. Let me show you what just clicked inside of my mind. There's this large IC on the motherboard that looked like it was designed to drive a fairly large motor. I'm starting to figure that out. I'll show you a bit later. We'll continue with this. Anyway, there's this IC for motor control that drives this. I'll show you later on the motherboard. But let's continue on with this. There's a couple of other things that goes into this. Now this is interesting right here. This is the front panel, but it's also the audio amplifier. So there's a whole amplifier board built right onto that. Oh, look at that. So right here, you can see the analog amplifier chip, the reverse, and the negative and positive. Looks like voltage bias that goes into there. I wonder if there's a little pinout for this. I have to read the pinout. There's nothing listed on this board. I know that the speakers were connected to this. Were speakers connected to this? Yeah, speakers connected to this. So this obviously our output. It's probably even a little bit of it. Is that TDA? The TDA 1517. That's quite common. Definitely an analog amplifier. All right, this board right here, and it doesn't want to come out. Okay, there's a couple of screws on that side. Get it off there. That's for the thermal fuse. That way, if there's a problem and it overheats, that'll kick off and prevent a fire. It goes right to there. So very common on fog machines, coffee makers, furnaces. Little things protecting your house or business from burning to the ground in a pile of rubble. I'm going to just switch back to the bigger screwdriver, I think. Yeah. So this board right here is the video selection board, video input board, and it's basically just the equivalent of a PCI card. It goes into a computer. There's probably a couple of digital components on this board as well that communicate with that main board. A lot of the digital processing may actually happen. This board might be smarter than the main board itself. We'll be able to determine that by looking at it once we get it out. Let's talk about some of the boards a little bit more. Here we have the one composite input video, S video, and sound board. So this board just takes the analog left and right sound, also takes composite video and the S video. I'm sure there's some other components inside, but it pretty much looks like it's just these three red, green, and blue handling chips, and then the direct input from the sound on that board, which goes to the daughter board. On the other input board, got some kind of strange signal section here. Not really sure what this is. It's like power conditioning and signal conditioning. It could be for the chips on the board. Got S video, not S video. Got the VGA in and out serial functions, as well as the color composite videos. And on the back here, got this little, looks to be analog to digital converter, and where it connects onto the daughter board. Let's talk about the daughter board a little bit more. This is the busy board here, and so it looks like what we have here, essentially. I think these are also other red, green, and blue, just composite video processing chips that go to other analog to digital converters. looks like you got some power components, could be regulators or whatnot on the board, and I'm pretty sure that this is all RAM for the system. So we got some other headphone outputs, it looks like, along with a power port of some sort. And here we have, looks like, the CPU and GPU and other signaling electronics for handling those signals and processing, along with what might be a little digital to analog converter here and other composite color processing portions. This is basically the processor. So it's a little strange to see what that EEPROM has. That EEPROM might be just for the RGB controller for the LCDs. So this is where all the brains of the board really is. We got to the main board here on the top. As I was talking about this earlier, this chip right here is a motor control chip. It's designed to control the motor in the front for the vertical lens position. So this is what explains the big motor drive capability. And here we have the smaller H-bridge controller systems for the front lens focus and position type stuff. Here we have some other electronics for just power signaling, and it looks like these are what control all the fan ports here. There's quite a lot of them, a lot of analog components on this board. So what I'm guessing though is this EEPROM has the software to maybe drive the three-way LCD panel itself. Not really quite sure on that one. Looks to be like there's a little reset switch underneath there. Not much going on here either on this board. Here's where it connects to the daughter board assembly to pick up all the signals. But that's not really an exciting board. Let's walk through the power supply board a little bit more. So this power supply is really interesting. I've already made sure it was safely discharged and stuff so that way I could handle it. Let's go through. Definitely looks like we got a voltage doubler circuit here, and we got a rectifier here. So from the mains power in to the board to the voltage doubler, which has a pair of draining resistors here, one for each capacitor, which is a nice feature. That just means that it won't store voltage for a long period of time. And from there, we have the rectifier, and we have this little resistor here, resistor fuse, and then a relay, which is controlled through probably the onboard or signal board, main board, which is for main power. Another safety protection component here. From there, we have the switching transistor, either a MOSFET or another high-power transistor, and this basically gets the signal from that little drive IC, I suspect there, to pulse the transformer. So that way, you get a pulse from here, which pulses the transformer, and essentially from the transformer pulses, the voltage gets filtered from the AC component to the DC components. Looks like it's got two diodes here, and then it's monitored on the low-end DC side. Got some other filter networks here for the power that goes out. That's the whole power rail here, and another, what looks to be a power rail as well here. This section right here is for the photocouplers for controlling the lamp driver. 3 photocouplers here, and that gets more onto the lamp driver side of the board. From the voltage doubler, and this is quite common, most lamp drivers get a DC voltage, either about 170 to 340 volt range, and so from the voltage doubler right over to here onto this line, making this whole lamp driver board from this point on, it's pretty much its own board in general, which is an interesting board. It works pretty much like any other lamp driver on the market for one of these high pressure discharge lamps. What we've got here is a set of inductors. Looks like, yeah, a set of inductors, and this is for the sustained current side of the lamp. It's kind of a weird setup how they got these lamps configured. These lamps usually have a board, and this board usually hangs off the side of the lamp controller, and this one's smack dab right in the middle. But this board basically controls the H-bridge. I believe it's an H-bridge. These 4 transistors or MOSFETs right up here, and these are coupled to the transformer. And this transformer is the high side driver for the lamp. Now, I believe that these lamps have to have 2 sources of input. both a high current input and a high voltage pulse input to keep the arc sustained. So there's actually two power supplies built into one that feed the power to the lamp, and they're kind of combined at the same time. Let's compare that to a regular lamp driver. You're going to see it's very similar. So once again, this board right here, speaking about the same photocouplers, got those three photocouplers here, which are basically the same three photocouplers on this lamp driver. And the main board communicates through this little port here, and you can clearly trace those connections from this port all the way down through these leads, down right to where the photocouplers are. So those are very easy to identify. The same thing here, we have the high current inductor, that looks to be an inductor side, and then the high voltage pulse network along with the pulse spark gap here, little 1400 volt capacitor. But yeah, basically it's the same thing, just a little different configuration, whereas you have the transformer, high voltage transformer here, you have it here instead, and then you have this component laying over here. So it's a similar setup, same four power components here, and the same four power components on this side, along with the full bridge driver. Same thing. Basically, it's the same thing. Yeah, basically, it's the same thing. Combination power supply and lamp driver. Really interesting. It looks like there's a couple of things settable on here. Maybe for settable power, and then the settable current and full speed of that particular lamp used. The interesting power supply. On to some of my favorite parts now. So, the Dichroic cross cube assembly. It's 4 pieces of triangular glass, a bunch of specialized optical properties. I have sat there with a heat gun on stupidly high settings. I have tried to pull one of these apart and I have just failed miserably. The cube didn't really seem to care, no matter how hot I got it. And I would love to pop one of these apart, but I don't know how. That's really surprising for me to say. I just don't know. But popping these off the base with a heat gun is actually really easy. Pulling them apart though, and they're 4 parts, so I don't know how to do that. Support that cube and then pull it off. Get all that out of the way. Now we have the cross cube here. That's a nice cross cube. Let's talk about the Dichroic cross cube a little bit more. I actually managed to pull the one from the projector apart, and it's really interesting once you get inside of it a little bit more. Not what I expected. So here's a polarizing cube that is not taken apart. You can see right through it. You can see pretty easily. That's where the green comes through, and then the other 2 sides is where you get the color to come through. And for the longest time, I had thought that each one of these sections on the inside had a different dichroic coating. So my initial thoughts were that the green would come in through, and then there would be one coating to reflect off light this way, and another to reflect off light the other way for the blue and red. So got a red and a blue side. That's not the case though. There's not actually 2 different dichroic layers between here. It's a really interesting setup. It's not what I expected. So if I open up the cube this way, you'll see that on this side there's a little bit of the dichroic coating that came off. You see it's a dichroic coating that reflects a kind of a cyan and passes a magenta, kind of passes the red and the blue, and reflects a lot of the green and the lighter blue off. Now the interesting thing is that if I were to open it 90 degrees off that axis, you don't see anything much at all. And there's no dichroic coating on this axis. There isn't. I was really surprised to see that. But it's actually completely plain coating. There might be some polarizing layers in there, but I don't really see any. So this is a cross section now. You see the dichroic coating on this side, and you'll see that it reflects, but there's actually no actual dichroic coating on that side at all. It's actually just glass. It kind of goes through. You'll also notice that now that the cube is pulled apart like this, it also looks very different from that side. So you can see that it's has a refractive nature that allows it to be almost like a mirror. It's reflective. So you don't see through the cube anymore. That has to do with the differential materials and the optical glue not being present, but they really do look quite different once it's taken apart. I'll flip it over. Same thing, it's just really reflective, whereas this one isn't. That was a really interesting thing to see. I've never taken one of these apart before, so learned a little bit. I think I figured out this lens. There's 3 screws in the front, so I'm going to undo those 3 screws, see if that pulls off that lens collar. I'm assuming that pulls it off. It's right underneath that little piece of plastic ring around there. So here's the front lens assembly. This is a lens that gets dirty, is exposed to things, fingerprints and all sorts of other goodies that you get when you place glass on the outside of something for a couple of years. And then it looks like the little tool position areas to get that lens out. So got a little flat blade, see if I can get that ring moving. That's where I try to not put a screwdriver in my hand. Oh, that ring's really in there. Oh, yeah, we're gonna come to that later on. Oof, I have not succeeded in not putting a screwdriver in my hand. Well, continuing forward, I guess. Pull out this assembly, which is the focus assembly. Boy, working with it like that would have made it a lot easier. Wow, that looks really stylish, though, doesn't it? That's just a really nice piece. Has a nice coating in there. Really nice coating. Look at that. That's a nice color sheen coming off of it. Put that aside. We got the automatic focus assembly, looks like, as well, along with a little lens inside. Pull off that little lens, get that little lens out of there. It looks like a negative meniscus lens, negative power lens, one concave and one convex side. We're looking at the convex side here, so it has a nice air coating. If you guys just want to see a video on the ridiculous amount of just lenses and other optics I have, let me know. I definitely have a lot of them. Put that in there. Pop that lens out. Cool. It's a pretty decent lens too. That's a nice clean one. I'll pop that in a safe place. Continue forward with this assembly. When I get this lens out, looks like I can just grab it by here and twist it off, though, with a little bit of luck. Nope. Well, still stuck with this. Terrible. I feel so defeated. I feel so defeated. It's okay, we have other tools available to us. We'll get this apart. Let's remove this assembly. Laser optics use such small tools compared to all of this nonsense. As far as the lens holders and stuff. The lens rings are such a nightmare. And I see like a specialty lens extraction tool. Oh, that's nice. Come on off, you heathen. Alright, and these screws here for the slide mechanism. I can't see just 3 being on here. I'm going to be searching for more. Usually there are 3 tracks. Yeah, I feel them. So we're going to have to undo all of those. And a total of 9 screws for that track. God, these tracks look cool too. Let's save these screws. These are nice little screws. Going out. Get out of your home. I see plastic in there. I am disappointed. Yes, I am. It's like working on a camera. At least you can see where the screws are, though. There's the good bits. Come on. Now these little sliders all need to come out. You know what? There's a better way of doing this. Well, nothing can be easy. Jesus Christ. We'll make it talk. Alright, now for a cool looking part. Look at that. I told you that was going to look cool. One lens. Two lens. Three lens. And the most awesome looking part. Look at that. That thing's just badass looking. As far as the lens by the cross cube goes, that could have gone better. That was really on there. Really on there. And another lens, which is in really good condition. And underneath there is another lens. So I'd pull that out. Already undone that ring in there. And that little assembly, little ring holder. And then this biconcave. No, not biconcave. Definitely another negative meniscus lens. Concave convex. Yeah. And the front assembly came undone a lot easier. I put this together so we can go through it and feel like we're doing one of those unboxing videos. You guys enjoy those unboxing videos on YouTube, so almost dropped that. So the front lens, I'll put that somewhere safe. Yeah. And then this ring, which holds two other lenses. These are also concave convex lenses. It's interesting, they're really just right stacked up on top of one another in this assembly with nothing between them. Glass on glass. Oh no, this one is biconcave. And they're both negative meniscus lenses. Nice. Well, that's about it. That's literally about everything inside of this projector. If you like this video and you want to see more teardowns, let me know. I'll do more.